Hi, this is Benjamin Behar. I'm presenting my assignment 2 for the course CSci 5611. I've been using processing to do this assignment, and I'll start it up and we can see what's going on. So, I've done 3D real-time simulation with cloth and deformable objects. So let's move straight to cloth. You can see it's floating down towards the ground because of gravity. It's got air resistance going on because that's where you get the balloon shape from. Now, I added some user interaction. So, for example, you can move the camera around. That's kind of just a normal suggested feature. But also, I added wind. So you can actually increase the wind in any direction you want. So let's go upwards this time. So it's not falling anymore because there's a gust of air lifting it off the ground. And let's see if I want to direct it towards the X direction. Press that a few times, it'll start to blow the cloth in a different direction slowly, and it'll slowly wave its way down to the ground because the drag is less now that it's sideways. Um, Now, another thing worth mentioning, let me turn off the wind here, is I set it up. If you look at the top left-hand side of your screen, well, first of all, you can see that it's 60 FPS, so it's been real time this whole time. But I added the ability to switch integrators during the animation because I wanted to compare and contrast the difference between forward Euler and the midpoint method, which is my personal favorite. So let's demonstrate that. If I set the cloth down and it lands on the ground, that's the only time I could find where it actually shows a difference. Because as you'll notice when it touches the ground, there is some, I wouldn't call it buckling, but wrinkling in the cloth that lingers for a bit, as you can see right there. Um, but if you use the forward Euler method, the error starts to take that away, as you can see right now. It gets flatter and flatter because it doesn't really handle a resting state very well. And it also doesn't handle bouncing very well at all. So let's move on to the deformable objects, which are personally my favorite because I've never done anything like this. So let's try it out. Okay, so this is our bigger block. Hits the ground, jiggles a lot because it's jello-y material. But you didn't see any deformation. So let me try moving it with the number 4 button. It should throw it to the side. And then it collides, it bends a little bit, and move it a bit more. You can see that it's denting the sides as it rolls. This is because I lowered the deform threshold on the springs to be ridiculously low, so it would be very jello-like instead of very building-like. So on this cube, it demonstrates it a lot better because as it rolls, it only hits the corners. So anyway, there you go. I think that's it. Thank you.